Work out the value of 12 minus 3k squared when k is equal to minus 2. So we know that k is equal to minus 2, which pretty much means they're the same. So what we can do here is take the k, completely replace with the minus 2, because remember they're the same, and that will give us our answer. So we can do 12, 3, and then I'm going to, in brackets, I'm going to replace the k with minus 2, and that will be squared. Now here it's very important that the order that we do things in. So first we'll do minus 2 squared, which will be 4. We multiply that 4 by 3. So we'll do 12 minus 12, and that will be 0. Next, we have to factorize fully pm plus 3p minus m minus 3. So first thing that I'm noticing is that the pm and the m and the 3p and the minus 3 sort of they work together. So I'm going to reorder this a bit. Now I could do the p to the p, but then the m and the 3 have nothing in common. So I'll do pm minus m plus 3p minus 3. Okay, then I'm going to do highest common factor here. So I can see pm minus m, so they have the m in common, so I'm going to put the m in front. Then I'm going to do p minus 1. And then here I can see they have the 3 in common, so I'm going to do plus 3, then the p and the minus 1. So we do outside of the brackets, we do what's the same about them, so in this case m, then inside we put what's different. So what makes it different is the p, what makes it different is the minus sign, so we put minus 1, then this p minus sign again. So if you do it correctly, you should always get the same sort of sequence in both of the brackets. So we have a p minus 1 here and a p minus 1 here. So our final answer will be m plus 3 multiplied by p minus 1. Now what you could do is multiply these back out. Now this is completely optional. This is only if you have time during the exam. You multiply them back out, see if they give you the same thing. So it's sort of a way of double checking your work. And if you match those up, MP, that's the same as PM, 3P here, minus M here, minus 3 here. So those will match up. So it's just a way of checking it. For part 2, we have to graph each of the following inequalities on the number line given. So we have to graph x is less than 2, where x is an integer. So x will be integers. So we have to be very careful about what we'll select. So 2 won't be because it has to be less than 2. So it'll be 1. So I'll just draw dots on all of these. Because 0.5, for example, will not be 1. And why? Because we're looking at integers only. And integers also include negative numbers. So I'll just select all of these. X is less than or equal to 3, where x is a natural number. So we want to select 1, we want to select 2, and we want to select 3. Because remember, it's less than or equal to 3. Now, 0 is a bit of a weird one. Sometimes 0 counts as a natural number. Sometimes it doesn't. So if you're ever unsure, because there are different definitions, you can always check in your formula book whether it's a natural number or not. So if you go to page 23, for these exams, we don't consider 0 a natural number, so we'll leave it out. But in some definitions, they do. So for now, while you're in secondary school, just always remember 0 is not a natural number. Okay. Then here we have this time real numbers, so we'll include all the ones on the number line. So we are told minus 2, so x is greater than minus 2 and less than or equal to 4. So when, for example, the number minus 1.9999, it'll get very close to minus 2, but it'll never touch it because it has to be greater than. So what we have to do is draw sort of a circle like this. This shows it gets very close, but doesn't actually touch. And then we'll just shade in the whole line, like so, because we have all of these numbers, they're all real numbers. Now 4, it actually does touch. It says x is less than or equal to 4. So we'll draw a dot here on 4. And that will be how we will answer question C. Then to finish it off, we have part D. We have to write the following expression as a single fraction in its simplest form. So the key thing here is whenever you want to add fractions together, they have to have the same denominator. And just by changing these fractions a bit, we can actually change the denominator. So I'm going to make the denominator of both of these 3 by 5x plus 2. And how did I get that? Just by multiplying these denominators. So in order to get this denominator on the left hand side, I'm going to have to multiply the top by 5x plus 2. So this here is going to change to 5x minus 2, 5x minus 2, multiplied by 5x plus 2 over 3 by 5x plus 2. Now the reason I'm doing that is so that I can have the same denominator at the end. So now I'm just going to multiply this out. So I'm going to multiply the top here just using a box method up here. So I'm going to do 5x minus 2 by 5, so 5x minus 2 by 5x plus 2. So this will be 25x squared, this will be minus 10x, this will be 10x, and this will be minus 4. So this top will be equal to 25x squared. Then I'm going to add the minus 10x and the 10x. They'll actually cancel each other out. And then at the end, I'll have minus 4 all over 3 by 5x, which is 15x, and 3 by 2, which is 6. And then this here is going to change to 2 by 3 by 5x plus 2 by 3. So the order in which you're multiplying doesn't really matter. So this will be 6 over 15x plus 6. So now I can change all of these and I can say 25x squared minus 4 over 15x plus 6 plus 6 over 15x plus 6. So now notice this. Now we have the same denominator, which means that we can just add these tops together. Once we do that, we will get 25x squared minus 4 plus 6, that would just be plus 2 over 15x plus 6. I'm just going to have a double check. Can I divide by anything here? And I cannot. So this is the fraction in its simplest form.